too. I know there's a lot of different things going around. So that stinks. Hopefully the rest of us can stay healthy and avoid getting sick. Yeah, because it's just not fun. All right, guys, let's go ahead and get started. So it is November 15th. Okay. So this week, yesterday you should have seen a lesson about light energy pop up in OLS. If you didn't complete that yesterday, please try to complete that today. It should kind of go along with what we've been talking about. Tomorrow, you're going to have a light energy quiz pop up in OLS. That is going to go in the grade book, so please make sure that you complete that. Do your best. If you make less than an 80 on it, send me an email, and I can reset that for you so you can have another attempt to make a better grade. And then on Friday, we will have a science TFAR. I had some people bring up that they had a math one popping up. That was an accident. You do not have a math TFAR, but you do have a science TFAR on Friday. So please make sure you show up to that, and we'll get that done. So you don't have to worry about it over Thanksgiving break. It's done, and then you get to fully enjoy your break. Please make sure that you're checking your email twice a day. I will be out of office tomorrow, so if you email me tomorrow, I will get back to it on Friday, and I will make sure that whatever you need, I respond to that. Okay, so make sure that we are being safe in class, in the K-12 zone, in chat, in breakout rooms, and when we're speaking over the microphone. Good morning, Symphony. We have a bunch of people coming in. Okay. Okay, Alicia, I would stay away from that dog and that neighbor and make sure that your parents know that, okay? Make sure that we are only sharing school-related information, no outside links, no personal information, that we're being appropriate in our background, in our clothes, in our conversations, and that we're being helpful, friendly, and respectful. Before you speak, write, or type, we need to think, is this true? Is this helpful? Is this important? Is this necessary? Or is this kind? If the answer to all those questions is not yes, we want to keep that thought in our brains a little bit longer and form it a little better before saying it or typing it. That way, we're being kind to everyone and we are respecting everyone's time. If you suddenly can't hear, your screen goes blank, refresh your browser, open and check your settings. Close Neuro completely and rejoin the Neuro class. If those three things do not work, you will want to call the K-12 tech support line. It is at 866-512-2273. All right, my classroom expectations are to arrive on time, listen carefully, turn on your camera, ask questions, use our tools, use your mic, answer our polls, and then use the chat. You are going to want to complete our Nearpod. We have a Nearpod that we're going to be doing today. You want to make sure that you complete the work in there as well. All right, so for our spiral review, we are going to determine the volume of the liquid in each graduated cylinder. Remember to look at the lowest point of the curve to determine the lines of milliliters that are in the graduated cylinder. Okay, so I want you guys to look at these 4 graduated cylinders. You may need to zoom in. We have these zoom in tools on the right side, that plus and minus. When you know how much is in each graduated cylinder, I want you to raise your hand, and I'm going to call on four people to answer how much liquid is in these graduated cylinders. Okay? So try to find for each one, and then raise your hand when you have the answers for each one. And we're going to check them. Okay, so for this first one, okay, it looks like the bottom of our curve is right here. Okay. So if the bottom of my curve is right here, when I look in between 10 to 20, and I count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are we counting by here? Are we counting by, we're counting by ones. Yes, we're counting by ones. So if this is 10, 11, 12, 13, 14, 15. So this first one is filled up to 15 milliliters. Okay. All right, let's look at this next one. Okay. If I look at this next one, it looks like it's filled right here. Okay. Kita, do you know what this one is filled to?
I got 4.
It is. It is 4 milliliters. Absolutely. Very good job. So if we look here, it's filled to this little tick right here. So when we count 1, 2, 3, 4, it is 4 milliliters. Very good job. All right. Right here, it's filled up to this line. Okay. So when I look here, it's in between 30 and 40. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what am I counting by?
Ones.
Counting by ones. Okay. So then I'm going to count. So 30, 31, 32, 33, 34, 35. Very good. Very good, Ahmad. It is. It's 35 milliliters. And why don't I fix that 3 because it looks like a mess. I can write a better 3 than that. It's better-ish. Okay, so on this next one, okay, it's a little bit different now. We're counting by, there's a 50, 100, 150, 200, 250. Okay, so when I count 1, 2, 3, 4 before I get to my 50. So what do you think we're counting by here? Tens. Very good, Elias. We're counting by tens. Okay, so this one is filled to this mark. Ooh, my goodness, the pen is not working great for Miss Vosberg today. We're going to get it, though. Okay, so it is right here. Okay. All right, so if I'm counting by tens, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Very good. Thank you, those of you who responded in the chat. Very good. So here we are measuring the volume of the liquid in the graduated cylinder. And remember, we're going to measure the bottom of that curve to find the measurement. All right. Good job, guys. Okay, so today, let me get I had my screen all zoomed in because I'm old and I can't see. All right, so we're going to look at TEK 5.6c, force, motion, and energy. The student knows that energy occurs in many forms and can be observed in cycles, patterns, and systems. The student is expected to demonstrate that light travels in a straight line until it strikes an object and is reflected and travels through one medium to another and is refracted. All right. Our guiding question that we're going to focus on today is, what is refraction and how is it related to light energy? So today we are learning about light energy, focusing on refraction so that we can understand how light energy travels. We'll know we have it if I can correctly complete the exit ticket. All right. So we are going to watch a video. So as we're watching the video, think about some ways you see or use refraction in your everyday life. Okay, be prepared to share your answer to the following question. Does light bounce or bend with refraction? Okay, you're going to use this sentence starter to answer that question. Light blank with refraction because it travels through different mediums. Okay, so my mediums are the different states of matter. So it could be a solid, a liquid, or a gas that light would have to travel through. So with refraction, is light going to bounce or is light going to bend? Let's watch this video and we will discuss it a little bit more.
Light is a form of energy that can travel through many different substances. Right now, light is coming from the bulb above me and traveling through the air. Light can also travel through glass. And light can travel through water.
Ooh.
Light is traveling through any material that you can see through, like this box or this plastic bag. We call any material that light is traveling through its medium. So the air, the glass, the water, and this clear plastic are all examples of mediums that light travels through. But something interesting happens when light travels from one medium to another medium. Here you can see that as light goes from the air into the clear plastic block, it bends. It bends again when it goes from the block back into the air. Light bends as it travels from one medium to another medium, and we call this bending of light refraction. Here you can see a red laser shining into an aquarium full of water. You can clearly see the light bend as it travels from one medium to another. The light refracts as it goes from the air into the water. The refraction of light is what makes objects that are placed into cups of water look bent or broken. The bending of light can be very useful. Lenses are used to refract light in useful ways. Lenses can be used to focus light. Or lenses can be used to magnify an image to make things that are small or far away easier to see. The different colors of light bend different amounts as they travel from one medium to another. Prisms are designed to bend light in a way that separates the colors to make them all visible. Rainbows actually appear when light travels between the air and tiny droplets of water. The light is refracted as it travels from one medium to another. This causes the colors to spread apart, creating a rainbow. So here I have a laser and 3 plastic toy dinosaurs that are all different colors. But when I turn the laser on, the laser beams only shine on the blue dinosaur. So here's your question. How could we use refraction to make a laser beam shine on each of the 3 dinosaurs? Take a minute and discuss that with your classmates. Then I'll be back to talk about the answer.
Okay, so does anybody have any predictions for how we could have that laser shine on all 3 of the dinosaurs? Okay, move them. Okay, but we're wanting to maybe not move them by hand, but somehow get the light to move to shine on them. It wouldn't be reflection. Okay, put glass or like a mirror. With a mirror, we would have reflection. So maybe not a mirror. Symphony?
Is it a cup of water?
Okay. All right. So there we'd have a different medium. Okay. Going from air to a liquid. Okay, let's see what he said. What he says. Again, we want to use refraction. So do we have any new predictions? I know Symphony said we could use a glass. Ahmad also said we could use a glass because remember, we're going through a different medium And when light goes through a different medium, it bends. So we can use that bending to help us. Aiden, did you have something to add?
Could move the dinosaurs closer to each other so the light shines on all three of them.
But we want to use refraction to get the light to shine on all three of them, not physically move them. So do you know how we could use refraction? Hadley, do you have any ideas?
Well, I think maybe use the two on next to the middle and then put them on the way corners maybe to get them to shine on all of them.
So are we moving the light or are we moving the dinosaurs with that?
The light.
So we'd want the light to bend to shine on the dinosaurs. Okay, Symphony, did you want to add something? Okay, here, let's see what we end up doing here.
Light refracts as it travels from one medium to another, and lenses are used to refract light in useful ways. So by placing a lens in the path of the lasers, I can bend the light so that a beam of light from the laser strikes each of the dinosaurs. I'm sure this is what you and your classmates came up with. And I hope this video has helped you understand so that a beam of light from the laser strikes.
Okay, so here we're using this lens, okay, and based on how it is shaped, it is bending this light so that it shines on all three of these dinosaurs. But we're using this lens when the light is moving from the air into this solid glass. So we're going from one medium to another. It is going to bend to be able to shine on all three dinosaurs. All right, so we're going to talk some more about refraction. Okay, so can someone finish that sentence for me? So light blank with refraction because it travels through different mediums. What does light do with refraction?
Bends.
It bends. Okay, so to finish this sentence, light bends with refraction. Excuse me, because it travels through different mediums. Very good. Okay, so we have a Nearpod today, so I'm going to get that link for you. Okay, thank you, Valentina. Okay, so go ahead and click on that Nearpod, and in this Nearpod, as we go through the slides, you're going to fill in the blanks and complete the table with diagrams, definitions, and examples, okay? And if we have time, we're going to go through some STAR questions and practice answering some of those. I do use our Nearpods for our attendance, so you need to make sure that you are signing into our Nearpod and participating and completing our Nearpod to receive attendance for this class. You need to make sure that you are following along with us. If you're just here and you're not doing anything, then you're not really here in class. So you need to make sure that you're signing in and completing the work with us. Okay, so I'm going to give you a second to get signed in. I have 1, 2, 3, 6, 7, 8. We have 8 people signed in so far. Okay, about half of us are signed in. You can start because you are going to be doing it with us as we go through. So yes, you may start if you already know what to do and know the answers, absolutely. But we will be talking about them as we go through. Okay, so about half of us are signed in. Please make sure that you are getting signed in. Aiden, did you have a question? I see your hand is up. Okay. All right, so with reflection and refraction of light. So our rainbow here is going to be an example of that refraction, of that bending of light when light is moving through our air to our water droplets. When that light moves through the water droplets going from air to liquid, and it bends that light to break it into the different colors that make up the rainbow. So light travels in a straight line. This person used their hands to form a bird shape on the wall. This is because light from the light source travels in a straight line. So we talked a little bit about on Monday about the difference between opaque and translucent. Do you remember what we said opaque means? Okay, so my pencil bag right here, if I shine a light on this pencil bag, is it going to move through my pencil bag? So when I shine this on my pencil bag, is it moving through and it's on the other side? No, it doesn't go through my pencil bag. That's because the fabric of this pencil bag is opaque, okay? Light cannot travel through it, okay? So it's going to be reflected off, or it's going to bounce back off the surface of this pencil bag, okay? But if I have something that is translucent, okay? If I have something that's translucent, so this box is clear, right? I can see through this box. Let me take this off real quick. There we go. So I can see through this box. When I shine the light through this box, can you guys see it? Okay, so this is translucent. I can see through it. Now, whenever we shine light, okay, so here they're shining light on those hands. The hands are opaque, so light is not going to travel through them. That's why we see that shadow on the wall, because the light is not traveling through their hands. It's hitting their hands and reflecting off, okay? So we see that shadow. That's the absence of light behind their hand, okay? So light does travel in a straight line. Okay, it is important to know that light travels in a straight line from its source until it strikes an object. Okay, when it strikes an object, it can react in different ways. We've noticed how light can reflect. It can bounce off. Yes, Elias, you should be working in the Nearpod as we're going through class. Yes, sir. Okay, so we said that it can bounce off from reflection, or it can travel through the object, and when it travels through the object, it could refract. It could bend. So if light goes through an object, is it reflecting? What do we think? If light goes through an object, is it reflecting? No. Okay, so reflection is when it's going to bounce off of an object. Okay, so it's going to strike an object and bounce back off. Reflection, we will not move through that object, but with refraction, it is going to go from one medium to another, and it can bend. So with reflection, we will not have light moving through an object. Okay, only with refraction is light moving through an object. Okay. Light can pass through car windows. The car doors, however, are opaque. When light strikes the opaque car doors, some light is absorbed and some light is reflected. Do we see the car doors in the picture here? Okay. What do we notice? What do you notice in that car door?
We can see a reflection.
You can see a reflection in the door, right? So here we see that some light is being absorbed. It's being soaked into that car. And then some of that light is being reflected on the surface of that car door. Why do you think, what physical property of that car helps that reflection, helps the light be able to reflect? What do we know about the surface of a car door? Think about things that reflect.
Metal?
So it's made out of metal. How would you describe metal? Most metal, when it's clean, it's shiny, right?
It's clear, yeah.
It's a shiny surface.
Shiny.
So it's going to be a smooth, shiny surface. When we talked about reflection, is that a surface that helps light to be able to reflect?
Yes.
Yes, it is. Very good. All right. Okay. So when light travels through one medium to another, light can be refracted. Light travels at different speeds through water and through air, making things appear distorted. Okay. So speaking of things looking distorted, what do we notice in this picture here? Do we have any examples of refraction from this picture?
Okay. It looks like his feet is broken.
Okay, yes. Thank you, Aiden. So right here, do his feet look lined up with his legs? Do they look like they're the same size? No. Okay. This is an example of refraction. So we have light traveling through the air. When it strikes the surface of this water, it is going to start to move differently. It's not going to be able to move as quick through the water as it's moving through the air. So since it's not going to be able to move as quickly through this water, because it's moving through the air and through this water, okay, it is going to make his feet look like they don't match up, and it magnifies them. When I say it magnifies them, what does that mean? Yes, ma'am? What does magnifying mean? Something is magnified, it looks what? When we magnify something, what does it look like? So refraction makes things look bigger, or makes things look broken. What does magnifying mean? If you zoom into something, what does it do?
It looks bigger.
It looks bigger, yes. So if it's magnified, it looks bigger. His feet look bigger because of refraction, because the light is moving slower through the water. Very good. Okay, so light travels in a straight line until it strikes an object. Reflection is the bouncing back of light. Okay, so yesterday we talked a lot about reflection. So notice here, this is my mirror. Okay, the light is bouncing off of this mirror. It's not moving through the mirror. Okay, so we have our light ray right here. It strikes the mirror. The same angle that it strikes the mirror, it's going to bounce back off of this mirror at the same angle. So same angle that it hit the mirror, it's going to bounce back off the mirror. It does not go through the mirror if we are reflecting. Okay, so reflecting, it's bouncing off like the ball. Like the ball, whenever we threw the ball yesterday, the ball didn't go, or on Monday, did the ball go through the floor whenever I bounced the ball? Did it go through the floor? Just kept going? No, it bounced back up off the floor. Very good. Thank you, Hayden. Yes. Thank you, Valentina. Thank you, Symphony. Yes. It didn't go through the floor. It bounced back up off the floor. Okay, so that's going to be our reflection. It's bouncing back off. Okay, so in the diagram, the incident ray strikes the mirror. The reflected ray bounces back. the light bounces off at the same angle that it enters. So this angle right here is the same as this angle on this side. These angles are equal, okay? Shiny objects and light-colored objects reflect a lot of light. So yesterday or on Monday, we did talk about colored objects. So lighter colored objects are going to reflect light more than darker colored objects. Darker colored objects are going to absorb that light, okay? So shiny objects and light colored objects are going to reflect light. Colored objects, dark colored objects are going to absorb that light. It's going to pull that light in. All right. So what reflects a lot of light? Okay. Chrome bumper. So on a car, there's a chrome bumper. That's going to reflect light. The light is going to hit that and bounce off. Okay. A rear view mirror. Okay. So when you look in your rear view mirror, we're using those mirrors so that light bounces off and that we're able to see that image behind us. And then a white car. So a white car, we saw that in the video on Monday. The color white is going to reflect light. That's why when he turned off the lights, we could still kind of see the color of that white car. All right. All right. Refraction is the bending of light. Refraction occurs when light passes through a new medium or material. When light passes from the air to the clear cube, light refracts. So here we see that we're going from the air to a solid. So it's going to move slower through this solid, and it is going to bend. Refraction occurs when light passes through a new medium or material. When light passes from the air to the clear cube, it refracts. Okay. Opaque objects cannot refract light because light does not pass through them. Light must pass through a medium in order to refract light. Okay, so like we said, with reflection, it's bouncing off that surface. It's not going through that object. But with refraction, it is moving through one medium to another. So it's moving through the object, and it bends when it does that. All right, so what refracts light? Prisms. So we saw in the video he had a prism. We looked at prisms not last week, but the week before. When light goes through a prism, it breaks it off into all the colors that make up that light. Eyeglasses. So here we can see how eyeglasses are refracting the light. If you wear glasses, you use refraction every single day. It refracts the light so that you're able to see those images better, makes them bigger if you need them to be bigger, so you can see them more clearly. And then telescopes use refraction as well to bend the light for us to be able to see objects from a far distance. Okay, reflection and refraction. Does water refract or reflect light? We've talked about this before. What do we think? Does water refract or reflect light? What did we say?
Refract.
What'd you say, sweetie?
Refract.
So it does refract light. Water does refract light. When it moves through water, it refracts. What else? What about if the surface of water is nice and smooth? What will it do?
Bounce back, so a reflection.
Reflect.
Both. So it will refract light and it will reflect light. Very good. Water can reflect and refract light. Light reflects off of a calm pond, as we see in this picture right here. Water refracts light as it passes through air and water. Okay, so here when we put our straw into our cup here, the straw when it's moving through air, and then this is the straw, the light as it's moving through air. This is what the straw looks like. The light as it's moving through water, it magnifies the straw and makes it look broken from the straw that's in the air. Do we see that? All right.
Yes.
Okay, so let's look at some STAR questions. Let's practice some of the things that we know about light. Okay, so the student is observing part of a plant with a microscope. Which statement describes a behavior of light in the microscope? Okay, A, light travels through the microscope lens without changing direction. B, moving in straight lines causes light to increase its brightness. C, light refracts through the lens of the microscope. Or D, moving in straight lines keeps light from reflecting. All right. Please answer the poll. Think of which answer best answers this question. Think about what we know about light energy, what we know about microscopes. Okay, it looks like 2/3 of us have answered. Please make sure that you're answering this question. Mariah, please make sure you answer. Ahmad, please make sure you answer. Valentina, please make sure you answer. Bubba, please make sure you answer. Eva, Kamal, please make sure you answer.
I couldn't see it for a second. I'm sorry.
That's okay. Okay, so it looks like most of us are saying that the correct answer is B. Let's look at this question. So, which statement describes the behavior of light in a microscope? What does a microscope do?
Makes things.
It zooms in and makes things bigger. I used to have a microscope.
Okay, so it makes things look bigger, right? It zooms in, makes things look bigger. Okay, so does that sound like something that we see with reflection, or does that sound like something we see with refraction?
Refraction.
Refraction. Reflection, I can see an image, right? But it doesn't make it look bigger. Refraction does make things look bigger. Okay, so let's look at my answers here. A, light travels through the microscope without changing direction. Okay, so we said with a microscope, it makes things look bigger. Refraction can make things look bigger. What does refraction do to light? Does it make it bounce or does it make it bend?
Bounce.
It makes light bend. Okay. So that could mean it's changing direction. With reflection, it's changing direction. Doesn't really sound like the best answer. Okay. B, moving in straight lines. Moving in straight lines because light causes light to increase its brightness. When light moves in straight lines, does that necessarily mean it's going to be brighter? No, it does not. So it definitely doesn't mean that it's going to be brighter. Okay. Light refracts through the lens of the microscope. So we said that a microscope makes things look bigger. We know refraction makes things look bigger because it bends the light. So C sounds like a pretty good answer. D, moving in straight lines keeps lights from reflecting. Is that true? Does light move in straight lines? Light moves in straight lines. Does light reflect sometimes? Yes. So it can't be both. So moving in straight lines keeps light from reflecting? That doesn't make any sense, does it? Okay, so D cannot be the best answer. The best answer here would be C. Light refracts through the lens of the microscope. Okay, let's do another one. All right. So for a class demonstration, a student turned off the lights in the classroom. The student then shined the light from a flashlight through a hole in a piece of cardboard. The class saw the narrow beam of light continue until another student placed a mirror in the light's path. The light did not continue past the mirror because A, light cannot travel very far. B, the mirror absorbed all of the light. C, the light was refracted back to the light source. Or D, light travels in a straight line and cannot go around objects. Okay, so which one makes the most sense here? So why do we think the light did not continue past the mirror? Pick what you think the best answer is. Okay, Aiden, please make sure you answer. Mariah, please make sure you answer. Ahmad, please make sure you answer. Bubba, thank you. Symphony, please answer. Eva and Kamal, please answer. Kawan, please answer. Damien, please answer.
Oh.
Okay. All right. So this one's a little tricky. We're going to talk about it. It looks like most of us are saying that the correct answer is C. Okay, so let's look. Okay. Light cannot travel very far. What do we have in the sky that provides us with light energy?
The sun?
The sun. Okay.
Sun.
Is the sun pretty far away?
Yes.
Yes. Does it make sense? A does not make sense because light can travel very far. We know that because we use the sun as our light source. Okay. All right. B, the mirror absorbs all of the light. Okay. So when I shine light onto a mirror, does it absorb the light or what did we see happens? Jace, can you tell me? When light hits a mirror, what does it do?
It reflects.
It reflects. So if it reflects, that means it's not absorbing the light, so it cannot be B. C, the light was refracted back to the light source. So we said refraction is when light bends, and it's because it's moving through another medium. Does that make sense that it's bending back to the light source? I haven't seen that. Okay. Let's check D. Light travels in a straight line and cannot go around objects. Is that true? Does light travel in a straight line? Yes, it does travel in a straight line. Can it just go around objects? Does it just go around the mirror and then shine on the other side of the mirror? No. So the best answer here is D. Light travels in a straight line and cannot go around objects. So when it hits that mirror, it's going to bounce off the mirror and reflect off, like Jay said, because that surface is a smooth, shiny surface, and that's going to reflect off of that mirror. Okay, so let's do our exit ticket very quickly. All right, so the diagram shows a cooler being viewed from above the water. Why does the cooler appear to be closer to the surface than it actually is? A, because light is a form of energy. B, because light is magnified. D, because light is reflected. I'm so sorry. C, because light is reflected, or D, because light is refracted. So please pick what you think the best answer is. Okay, so why does the cooler appear to be closer to the surface than it actually is? Because light is a form of energy, because light is magnified, because light is being reflected, or because light is being refracted. We want the best answer. Okay, it looks like some of us are saying B or C. Most of us are saying B. Okay, so we want the best answer. The reason that this is happening is because light is being refracted. The light is being bent, okay, so that it looks like the cooler is in a different place than it actually is, okay? So here we can't see that it's being magnified, though refraction can cause objects to look magnified. Here we don't see that it's being magnified, but we do see that it's in a different location. So this is refraction. It's being bent so that it looks like it's in a different place, kind of like that guy's feet looked in the picture. All right, guys, that's all the time that we have for today. I'm very sorry we went over a little bit. You guys have a great day, and I will see you later. See you on Friday for our TFAR. Bye, guys.